Hello everyone. I'm going to talk about the ambiguous case for the law of sines. So one of the situations when we can use the law of sines is when we are given two side lengths and the measure of an angle that is across from one of those sides. This is basically the side-side angle scenario. So let me draw a triangle where that is the information we know. So let's start here, and let's say we know this angle. So we know angle A, we know how big this is. And let's say this is one of the sides that we know. I'll just put a number here. Let's say this is 2. And then across from angle A, we know this other side. Let's say this is a measure of 30 that we know, and then across from that, we know this side length is 1.5. So let's say this is B and this is C. So looking at the information we're given, we know one angle, we know two side lengths, and this angle is across from one of the sides that we know. So we should be able to use the law of sines to help us find the rest of the missing information in this triangle. However, if you remember back to geometry, these three pieces of information, this is not necessarily enough to define a unique triangle. So what ends up happening is if I draw in the altitude to this triangle, this is basically the height. Because this side opposite the angle, because this is smaller than my second side that I know, and because it's bigger than the height of the triangle, I could actually take this length, and you can think about it as a reflection, or if I kind of rotate this in, I can swing that through, and I could actually draw a second triangle that has those same three pieces of information. Now, my lengths, they don't look exactly the same, but these two would be congruent to each other. So what that means is we have two possible triangles with those three pieces of given information. So when we go to solve a triangle using the law of sines, we need to make sure that we know what to expect. Am I going to get two triangles? Am I going to get one triangle? So let's think about our different possibilities here. So again, let's start with just one of the sides. Now, I'm not quite sure how long that's going to have to be, but over here, I do know how big angle A is. Adjacent to angle A, I know how long this side length is. Let's just say that's B. And then we can also determine the height of this would-be triangle just using angle A, and we can use sine to figure that out. So now comparing these two side lengths, B and H, to the length of our third side that we know, we have a couple different possibilities. The first one is, let's say A is smaller than H. So now, because A is smaller than H, if we think about swinging this down through, it's never going to meet that third side of our triangle. It's never going to close. So in this case, we have no triangle that exists. Well, let's say we extend A little bit, and we make it so that it is the exact same length as H. Well, now when we swing that through, it's going to meet this third side in exactly one spot. It's going to come down here, and we're going to have exactly one triangle. Okay? I can make it a little bit longer, so now it's a little bit even longer than H. So when I try and close this off, I actually have two spots where that's going to meet, like we saw up here. If I swing that through, I can have one triangle where it meets here. So that's one possibility. Or I could keep going, and then swing it through to the other side, reflect that, and I get a second triangle. So in that case, A is bigger than H, but it's not quite bigger than B, and we get two possible triangles. And our third option is if A is bigger than B, So now this entire length is greater than b. Now we only have one possible triangle that exists. If I swing this through, it's not going to meet up again until it's on the other side of b over here, which again will not make a triangle, so there's only the one possibility there. So let's summarize all of that. We'll put that in one spot for each case. So we have some rules for testing this. For each of the rules, we're going to be comparing the side that's opposite the angle to b, and then in some cases we also need to compare it to the height of the triangle. So let's say we have a triangle and we are given two sides and then the measure of an angle. Again, the notation here, because this is capital A, I know that's the angle that's opposite side length A. So first, if A is an acute angle, we have four possibilities. So the first one, so here's angle A, here's side length B, here's the height of this would-be triangle. Now if A is smaller than H, we're not going to end up with any triangle at all. So if A is less than B and A is also smaller than H, there's no triangle that exists. Our second possibility, if we make A a little bit longer, and now A is exactly the same as H, when we swing this down, it is going to meet in exactly one spot, and we're going to have just the one right triangle. So here A is less than B, but now A is the same as H, and we get one triangle. If we keep going and we make A a little bit longer, so here's B and the height of the triangle. Now A is a little bit longer than H, and in this case we end up with two possibilities. So we have the one on the outside, or if I take that segment and I reflect it over that altitude, we get a second triangle that exists here. So if A is less than B, but now A is greater than the height, we get two triangles. And the last possibility, if A is longer than side B, now we only have one triangle that exists here. So A is longer than B. There's no possible way to get a second triangle that exists. So A greater than B, we get one triangle. So, four different scenarios for when angle A is acute. But what if angle A is right or obtuse? What ends up happening is we basically get rid of this situation here. So, in order to have two possible triangles, one of these is an acute angle, but then when I reflect that in my second triangle here, that actually ends up being an obtuse angle. If angle A is my obtuse angle, this isn't possible. So when A is either right or obtuse, we end up with only just two different possibilities. So if A is right or obtuse, we either have no triangle, so let's make this an obtuse angle. There's B. Okay, so now if A is smaller than B, when we try and swing that through, it's never going to meet up with that last side. So if A is smaller than B, or equal to B, we get no triangle. And the second possibility is if A is bigger than B, we end up with just the one triangle. So here A is larger, so it actually meets up, creates that triangle. A greater than B, we get one triangle. So that gives us a couple different rules, a couple different ways to test which scenario we should expect. In each case, we are comparing the side that is opposite the angle to either the second side that we know, so comparing A to B, or we are also comparing it to the height of the triangle. Once you know what to expect, you can either solve the triangle and end up with one possibility, or you can solve and you can find the two possible triangles that exist.